Hi everyone. There are so many examples in our lives of quantities which are related to each other. For example, if I am selling a certain product, in order to know my revenue, I need to know the quantity sold. So given the quantity Q, I will be able to calculate the revenue R. This is another example. I can calculate the distance crossed by a rocket at a certain time t. So given time t, I will be able to calculate the distance d. One more example, I can find the speed of a chemical reaction given the temperature of the reaction vessel. So given the temperature T, I will be able to calculate the speed S. All these examples are called relations in math. So in a relation, as you can see, we have two changing quantities which are related to one another. And these quantities are ordered pairs. The first component in each pair is the input value, and the second component in each pair is the output value. Now in each of these examples, if I put all the pairs in one set, this set is called a relation. Thus, a relation is a set of ordered pairs. We usually denote the first component of an ordered pair by X and the second component of this pair by Y. As we said, the first component is the input value or the independent variable, and the second component is the output value or the dependent variable. So this is always the case. The first component is always the independent variable, and the second component is always the dependent variable. So give me X, I give you Y. Moreover, if we put all the input values in one set, we obtain the domain of the relation. So the domain of the relation is the set of all the input values, and on the other hand, the set of all the output values is called the range of the relation. Let us consider this example. What is the domain? As you can see, it is the set of all first components in the pairs, so it is 1, 2, 3, 4, and 5. On the other hand, the range will be the set of all second components in the ordered pairs, so it is 3, 6, 9, 12, and 15. Now, among the relations, there is a special class which is called functions. So if we assume that this set contains all the relations that we have in the world, the functions are a special class of these relations. Now, how do I know whether a relation is a function or not? There should be some condition that has to be satisfied. What is this condition? Let us look at the next definition. So a function is a relation which assigns one and only one output to each input. Let us consider this example. And let's look at the list of the drinks with their corresponding prices. If we think of the drinks as the input values and of the corresponding prices as the output values, this is a function. Why? Because no drink has more than one price. That's the price of the coffee, that's the price of the tea, that's for the orange juice, and this is for the apple juice. So each input has one and only one output. Thus, this relation is a function. However, if we think of this example in the other way, which means if we think of the prices as the input values and the types of the drinks as the output values, this is not a function, because if I'm given a price, this could be the same price for two different items. So that's the price of the coffee, that is the price of the tea, and as you can see, the same value is the price for both the orange juice and the apple juice. Therefore, this relation is not a function. This is another example. If I'm given a bank account number, for each bank account number, there is one and only one account balance. It is not possible to have two different balances for the same bank account number, so this is a function. However, the other way is not the case. We might find the same account balance for two different account numbers. So the other way is not a function. It is only a relation. These are two more examples. The first example corresponds to a function because, as you can see, all the inputs have only one arrow going from them. However, the second example is not a function. Why? Because there exists an input value, which is B in this case, which has more than one input value. In general, this is how we denote a function. So we say that y is a function of x. Or in other words, y depends on x. And it's really very important to know which variable is independent and which variable is dependent. This is essential, especially when we start doing derivatives in calculus. This concept, y equals to f of x, was first introduced by the Swiss mathematician Leonhard Euler. Let us now talk about the graph of a function. What is the graph of a function? It is simply the set of all the points xy which satisfies the equation y equal to f of x. There is another way to identify whether a graph represents a function or not. It is the so-called vertical line test. What does it say? It simply says that if we have a graph, and if we want to know whether this graph represents a function or not, all we have to do is the following. For any vertical line we draw, if this vertical line intersects the graph more than once, this means that it does not represent a function. So in order for a graph to represent a function, any vertical line I draw must intersect this graph at most in one point. Let us see some examples. This is an example of a function. For any vertical line I draw anywhere, there is no one which intersects the graph at more than once. So this is a function. What about this graph? This is not a function because there exists at least one vertical line which intersects this graph in more than one point. The circle is also not a function. Obviously, there are many vertical lines which intersect the circle at more than once. One last concept in this video I want to talk about is the so-called one-to-one functions. Again, let us now consider the set of all functions. There is also another special class of these functions. It is the class of one-to-one functions. What are these? So a one-to-one function is a function. So first of all, of course, it must be a function first of all. Otherwise, it doesn't make sense to talk about one-to-one functions. So it is a function in which each output value corresponds to exactly one input value. So now we have to look at the outputs. In other words, there is no output which has more than one input. Let us see some examples. In this example, we do the following. First of all, we check whether this relation is a function, and yes, it is. Each input has one and only one output. So after we make sure that it's a function, we move on to the second step, which is checking whether it's one-to-one or not. We now look at the range, and we notice that each output is receiving exactly one arrow, or in other words, has exactly one input. So yes, it is one-to-one. What about this example? Is this a function? Yes, it is a function. But this is not one-to-one function. Why? Because the output value 2 has two inputs, C and D, so this is not one-to-one. Now this is how we check whether a function is one-to-one or not, given the diagrams like that. Is there any way to check whether a function is one-to-one or not if we have a graph? The answer is yes. We can apply the so-called horizontal line test. It is very similar to the concept of the vertical line test, but instead of drawing a vertical line, we draw a horizontal line. Thus, if there exists any horizontal line which intersects a graph at more than once, this means that our graph does not represent a one-to-one function. For example, this graph, which is called a parabola, is not one-to-one because we can find so many horizontal lines which intersect this graph at more than once. What about this? Yes, it is one-to-one because there is no horizontal line which intersects the graph at more than one point. One last example. Is this one-to-one? There is no horizontal line which intersects this graph at more than once. But wait a minute. We should never forget to check whether this graph is a function before moving to the one-to-one step. This is not a function based on the vertical line test. As you can see, we conclude that this graph does not correspond to a function. Thus, it doesn't make any sense to check whether it's one-to-one or not. That's all about relations and functions. In the next video, I will show you how to find the domain and the range of a function.